everyone. That's JNation for you guys. Thank you for coming to this session. We are going to be talking a little bit about durable executions. Can I get a raise of hands about how many people know about what durable executions are? Okay, so we have a couple of people here. Okay, so that should be interesting. I will do my best to explain what it is, but first we just need to jump into a little bit of the context of why we are presenting about this topic and all the other things that will surround this topic, no matter which frameworks, languages, and technologies you decide to use. I'm here with my friend Nele.
Yes, my name is Nele. I'm a developer advocate at Fiberplane. We are a small startup based out of Amsterdam. We build tools around Cloudflare, and you also find me on the socials.
Cool. And my name is Mauricio Salatino. I'm at Salaboy on Twitter and salaboy.com in Blue Sky. I'm working for a company that's called Diagrid. We are behind the CNCF project that it's called Dapr. That's a lot of Kubernetes stuff. And yeah, some of the things that I've done. I wrote a book titled Platform Engineering on Kubernetes. That's very Kubernetes infra focused, of course. So I kind of like that topic a lot. But currently I'm writing a book titled Developer Experience on Kubernetes with my friend here, Thomas Vitale. So if you have questions, I think that Thomas have a bunch of codes to give away. This is in the early access. That basically means that you can access the book while we write the chapters. And you get updates every time that we publish something new. I'm super excited about that book because I believe that developers have a hard time with Kubernetes in sometimes, depending the background that they have. But I strongly believe that learning Kubernetes is something that can help you to architect better applications and understand how the cloud world works.
You forgot to mention that you also recently became a Java champion.
I became a Java champion soon, so
you should also have that there.
Yes.
Yeah, so if we talk about building and running distributed applications, you mentioned already Kubernetes as one way of doing that, but that's not the only way how we can build distributed applications nowadays. And I work as a startup, and we are not using Kubernetes because we are a small team and we don't want to manage our own infrastructure, so we went for a serverless approach. And I think the idea is quite simple. The infrastructure is handled by a cloud provider, so we don't have to manage the servers. That has some benefits, but maybe also sometimes some disadvantages, because if something goes wrong or breaks, you can't really dig deep into what's going on your infrastructure. But as said before, you are not having the overhead of managing all of that yourself. Then the idea is scaling based on demand. So how much you execute, you pay for, or when your application is running, you actually pay for that. And that, again, can be good if you have a good cost model that goes well with your execution, can also lead to higher cost if you don't have a good control over it. And then the idea is it scales back to zero when the execution stops. And yeah, there is an interesting article from Martin Follower that you can read about it. And yeah, we choose a serverless platform. And I'm curious to know how many of you know Cloudflare?
Oh, wow.
Wow.
Okay.
And how many of you knew already before that you can run serverless applications on Cloudflare? Not that many.
Okay, not
cool.
that many. How about Kubernetes people? How many Kubernetes people do we have in the room? Okay. Similar, I would say.
Yeah.
So we have maybe half and half. That's good.
But yeah, actually, you can run your serverless applications on Cloudflare, and Cloudflare has a whole ecosystem for you, not only to run a serverless function. That is something that you would find in the worker, in the middle, in the compute time, but it provides a whole ecosystem to build distributed applications. For example, you find queues, workflows, pipelines that become important when communicating, but also things like data storage, and all of that is included in the platform. And we are going to explore today a little bit what you can do there as well. And I think we talk about durable execution, and something that comes to my mind is state directly, and then talking about serverless and state feels a little bit intuitive, because if you shut down a thing after it terminates, how do you handle state? Of course, we can start writing things into external applications or databases, but that will introduce, again, an overhead. And Cloudflare has a nice way of doing that. They introduce durable objects. So they store or have the idea that you have an object of a class. It's a singleton. It has one address, one name, and you can connect different clients to it. It can write in memory, but also on disk. And for example, you can build, or you can use those durable objects yourself to build things like real-time collaboration tools, but also for WebSockets. And I showed you the diagram with all the services that the Cloudflare platform offers. And durable object is an important building part for themselves, how they build out those services. And I think one thing I enjoy working with Cloudflare is the Cloudflare blog. It's really interesting to read how they wrap their head around those concepts. And yeah, that's pretty cool. But if you grow maybe your startup one day, you are not happy with that anymore, and you start having a team for managing infrastructure. Before that, we also created a stack to get data APIs running quickly on Cloudflare. So if you want to try that out, we have Honk, not only consisting of the Cloudflare Worker, but also Hono as a web framework. You can build basically data APIs around that. It has a database. Multiple are available, Neon, Supabase, or D1. D1 also is a Cloudflare developer primitive. And then to connect your application, it uses an ORM that is Drizzle. And then it runs on a Cloudflare worker. Drizzle recently was complaining about the abbreviation. We choose it because we wanted to have a company mascot. So now we have officially a goose. You will see the goose maybe around that presentation multiple times. Yeah, and the Cloudflare Worker is the cloud environment where everything runs.
There you go. And I think that that's super nice. Like when you're adopting kind of like this kind of, okay, that's also yours. That's how you create projects, I guess.
That's how you create a project, yeah.
So if you go to the other side, right, like a more traditional approach where you manage your own infrastructure, or when you want to have full control of the machines that are running your applications, you have like the Kubernetes approach, right? I really like this image from Atlassian that basically shows like VMs on one side, like what more like traditional companies still run, to containers in the middle, to when you have tons of containers that you want to distribute in a cluster of computers, you can use Kubernetes to do that. Kubernetes became kind of like the de facto option for running containers at scale because it gives us that API that we can use to basically deploy our software in a cluster of computers without knowing the shape of the cluster. And for me as a developer, that's a pretty powerful API. But in contrast with what Nele presented, this is not an ecosystem on its own, right? Like Kubernetes only gives us the compute to run our applications. So we need much more around it. So we need to kind of like build our own ecosystem, choose from different places, from different tools, to have something similar to what Cloudflare is offering. The cloud-native approach gives you that freedom of you go and pick your tools to build these kind of like platforms, these ecosystems that will allow you to run software at scale. But it's not that easy. You actually need to spend a lot of time understanding how this works, and you need to have teams to manage this infrastructure, no matter if you're running it on-prem or if you're running in a cloud provider. And still, like even with all of this, how is this related to the topic of the presentation, durable executions? Even if we manage our own compute, even if we use Kubernetes, we are not safe from failure, right? Like Kubernetes will check if our applications are running and suddenly restart the pod or restart the container, but it's not going to fix logical problems of our application. And it's really, really hard to do that at scale, no matter if you're using SaaS offerings or something like Kubernetes. Because building distributed applications is super hard. Everything can fail, from machines to nodes in Kubernetes to the network to disks to cloud services, right? Like sometimes you said like Google Cloud cannot go down, and it goes down, and then you start losing money because you trusted that so much.
And you also have the problem if you have sometimes the situation that you wait maybe for user input or for external systems to come back to you. How do you handle that? How can you wait effectively and maintaining the state? So how and what can we do about state and distributed applications?
Yeah, so on top of any solutions that we chose, and I think that Cloudflare, they have their approaches to build resiliency into their applications. If you are in Kubernetes land, you will need to start looking into different tools, because we actually need like a unified way of dealing with errors, and that can be network errors, so you introduce things like retries or cascading errors with circuit breakers, and basically start thinking about how do you architect your applications for failure. Right? The moment that you start designing your system, you actually take failure into consideration. And most of the time, that can be achieved by having some sort of like orchestrator or component that understand what the system is trying to achieve, how is it working, and then actually syncing the different components that belong to your distributed application. That's some sort of like an orchestra director that it's looking at all the instruments, how they are playing, and they are just making sure that they are in sync, that they are at the right volume and the right speed.
Yeah, and I think that is interesting because we kind of also have a history because orchestration software has been around way longer than we are talking about durable executions. We actually meet like 5 years ago working at the same company doing workflow automation, workflow orchestration, and it has a history. I mean, would say in the 90s there was some standardization about it, but the idea is the whole topic of workflow management systems, and mainly it comes from the area of orchestration automated tasks and also human tasks. And what you see here is often a workflow was defined in a language like BPMN, so you have a graphical language that then an engine could automate. And then now we talk about about durable execution, and that happened around the time of 2010 when we started also introducing the topic of microservices or building out microservices, and the term was introduced by Microsoft. And what has really changed is around the idea how we handle workflows is that if we have durable execution, we move our workflows to code. So now we are starting to define what is happening in our workflow and code. We look into this more in detail later, but first, let's maybe have a clear definition what we mean when we talk about a workflow. So the idea is that a workflow has a defined start point that you can call, and once you call that start point, you create an instance of your workflow, and then you have a flow with activities on it. So you have a predefined set of activities you want to execute. That can be service tasks, but could be also other things in between. You have a control flow, and they are following this order. And in the end, a workflow also has an endpoint, and when this is reached, our workflow instance will end.
It's kind of funny because workflows have been around for a long time, and it's one of those things that will keep coming back. Because no matter what kind of application you are building, you always have some sort of like state machine that needs persistence. So in my career, like over like 20 years, I've seen so many companies implementing these kind of things internally, because you always need some sort of tool to sort these kind of situations. And the problem with that is that when you build something internally, then you need to maintain it over a long period of time, and making these solutions scales is like pretty hard.
And coming now that we have the workflow also to durable executions.
Yeah, exactly. So that's like the topic of the presentation. We started with workflows because I think that that's something that if you have been like in the industry for a while, you probably have heard of. And durable executions is like an architectural pattern to basically build resilient applications, right? I don't think that it's not something new, but it's something that it's becoming more and more important the more complex distributed applications we build. Again, it's something that you will use to make your applications resilient to failure in a way that in some sort of way that for developers is transparent, right? I will try to explain how this pattern works in 5 slides, but it's a simplification of the capabilities of what you can do with durable executions, but just for us to have an idea about how it works. So imagine that you have this code. I don't know if you can see it correctly, but the first line says validate service, validate customer, and you send the customer. The second one says entity manager save, so you are saving the customer to a database, for example. And the third one says Kafka template, send an event to a Kafka topic, right? So we are doing 3 different things, 3 different actions. That's source code inside your application. What durable tasks do is translate that into separate tasks that can be executed independently, not inside the application. The reason to do that is because if you have these 3 steps separated from the application, you can actually now have a task queue. It's ordered in the other way, right? So the first task that will be executed is the one at the bottom. We need to execute validate customer. And that task queue is going to be monitored or like consumed by a worker pool. Like the idea of a worker is that a worker can take a task and execute it. And if the task fails, it will retry that task execution. So let's say that we take the validate customer task outside of the queue. We put it on worker B. Worker B will start processing. And whenever it finishes, what it will do, it will move that to the done bucket. I'm calling it the done bucket, but that's like a transaction log of all the things that were completed successfully, right? And then it will pick the next task, that is notify other systems, for example, and it will pick it up from there, put it in worker A. In this case, this task is failing. So the worker will keep retrying the task as much as we configure it to do so until that task is done. When the task is done, it's going to be placed in the done bucket. And the same with the last task in the bucket. But this architecture is designed to support these kind of things, where we execute the first line, then the application crashes for some reason. And then the task queue also, we lost the state of the task queue, and we lost all the workers for some strange reason, right? Like all the servers are shut down. Nothing gets lost, because what happens is when the application restarts, we check which lines we already executed, and then we recreate the task queue so the workers can continue working on the tasks that were not executed. So the idea here is that the application gets restarted, it checks if the first line was executed, it is done already, so we can just go to the next line and execute the next activities using that approach. Again, the idea here is that you create an architecture where it's built for failure, and you are decoupling the execution of the application to make it resilient using like this pattern. And this is extremely related with workflows, because workflow engines can use this as a building block to build higher level behavior like the one that Nele showed in the, in the workflow diagram.
Yeah, and when we talk about, again, the serverless platforms, what you see that almost all the platforms that exist have their own workflow tools out there. So AWS has step functions, there's Google Workflow, there's Azure Logic apps, and then there's also Cloudflare Workflows. And maybe you have used the one or the other one already, but the idea is that we also want to be aware when we start building the serverless applications that if we have things that belong together, if a thing is failing, we are aware that it's failing, that we can restart it, and that we can continue where we stopped. And yeah, with Cloudflare Workflow, it's quite simple. We don't have to manage the workflow engine ourselves, but the idea is that you use the workflow class to create a workflow. You create the workflow definition, so you define and code in TypeScript, for example, how you want to build your steps, and then you can also wait for external input, and that can come over an API call, but you can also use the workers to call that step. And yeah, that is the idea in general. If you want to start a workflow instance on a platform like Cloudflare, you can interact with the REST API to start workflows, but also retrieve information about where your workflow is. And you can also use directly your Cloudflare worker and create a binding. That's how Cloudflare internally calls those services. And once you have that binding, you can simply call the binding from your code.
That sounds good. And also, it's kind of interesting to see the evolution of these ecosystems, right? Like Cloudflare just released workflows last year, I think, or a couple of years.
So they released it last year, and it became general available now. So
you see, like they are building an ecosystem, and at some point they reach to a point where they say, oh, we just need to provide some sort of functionality to coordinate all these workers that we already have that are like serverless functions. And the same happens, like actually the same scenarios start to pop up like in the Kubernetes space quite a lot. That's why I'm working on a project that it's called Dapr. That in some way, it's similar to what Cloudflare is doing, is offering an ecosystem of APIs to implement functionality that your applications will need. I do not have time to go over all the functionality that Dapr implements. You can see the first building block there is workflow, so we will be talking about that. But what I want you to take away from this presentation is that Dapr is something that you install on your Kubernetes clusters, and then you get all this functionality exposed by APIs. You can consume these APIs from different languages and different tech stacks, and all these functionalities are built on top of 3 cross-cutting concerns: observability, resiliency, and security. And workflows specifically, it's built on top of all the resiliency mechanisms that Dapr offers. You can run these outside of Kubernetes as well, but actually, that's pretty much what Dapr does. It provides that ecosystem of APIs. When we talk about workflows, the architecture is pretty simple. I just want to compare that with the example that I did during the durable execution explanation. So we have our application that interacts with the Dapr APIs for creating workflows and starting workflows and monitoring workflows. And Dapr uses like an append-only state store to store the transaction logs of the things that were completed, right? And again, we can define the tasks inside of our application, register the workflow definition or the code that represents our workflow sequence into Dapr, and Dapr will take care of scheduling these activities and these tasks into the worker pool. Of course, we have APIs as well, so you can start using HTTP or gRPC APIs or using the SDKs provided by different languages. And with that, I think that now that we know workflows, durable executions, we know that we have workflows in Cloudflare, we know that we have workflows in Kubernetes with Dapr, we can talk a little bit about the patterns that you can implement that are pretty common when you're working with these tools.
Yeah, and I think we look into diagrams now, but then after that we jump into the code. I think important to say here is you can implement those patterns with Cloudflare, with Dapr, and probably also with all the other solutions that are out there. So they are really common. And the simplest one we already saw in our definition, it's like chaining tasks one after each other. So imagine you have tasks, they are depending on each other. So maybe an ordering process, activity A creates the order. You need the output from activity A, the order ID, to start activity B, and maybe activity B is creating the shipping, and then activity B with the shipping ID and the order ID, activity C depends on that. So you want to create a notice for the customer or a notification, and then this workflow is ending. Of course, a order process can be way longer and can have way more activities. But the idea here is you rely on the output of one activity for the next one, and that is quite simple. We also have the pattern that if you don't rely on an output, you can run things in parallel. So here the idea is you can start activity A and B in parallel, and then only activity C is depending on the output of activity A and B. And it becomes more interesting if we think about external events. And an external event can be a system or a user. But here the idea is we, for example, do a credit score check, and then we wait maybe for an external system coming back with some credit results. So once we receive the credit results, we look into those results and we see if it was approved or if it was not approved. If it was approved, activity B could be like, allowing the credit for the credit application, and C might be the one that we deny the credit application. And activity D, again, is inform the customer about our outcome, and then our workflow ends. And this already, I think, brings some potential problems if we look at this again, because what happens now if we wait forever for our external system to come back, or maybe we have a user who is on holiday and is not logging into the system, is not finishing the workflow, or is not continuing in the workflow. And a really nice thing here where we can manage the state and where we can interact is that we can create timeouts. So whenever we have an event we wait for, we can also define a timer, and if it takes too long, we can do something else. So we can take the process instance from there and decide to go a different path. For example, we do activity E that could be escalating to someone if we wait for a user. But for example, if it's an external system, we might also want to do something else here, and then we also end the workflow.
Sure. So just to summarize, like Nele just showed, sequencing of tasks and control of sequencing, with checks, or let's say if statements or switch statements. We also looked into external events that require some component to be waiting for this event to arrive, and then timeouts that basically require some sort of a scheduled job waiting for something to happen and then triggering an action after a day, after an hour, if the conditions are met. So now I think that we can take a look at the source code, right? Can we take a look at the examples in Cloudflare and in Java as well?
Yeah, and let's start with Cloudflare. So we extend here the class, and AI is very generous, and like those demo apps, the idea here is we create a spirit goose based on your name. So our first task actually here is a step 2. So we get the spirit goose, so that is a descriptive name, what the task will do. We have then a function that we are calling, get the spirit goose based on your name. We use AI bindings here from Cloudflare because it was the easiest to solve here. And then after that step is finished, we use the spirit goose again for a second step in our workflow. So we created the second step, create spirit goose assets. And here we use a promise, and we will have two things that can run in parallel now. So we have the create ASCII art based on our spirit goose that we got, and also create a bio for our spirit goose. And after that, we return that, and we finish the workflow. And I think we can start that now.
Sounds good. So just to summarize, she created a workflow with different tasks that will be scheduled as workers in this case. So the workflow will be distributed, and it will just schedule these tasks so a worker pool can pick it up and run it.
And we are calling the workflow. We have an endpoint here, a post endpoint called Spirit Goose. And once this endpoint is called with a name as an input, we are actually starting here directly from that application, our workflow. And I'm going to open the application now. And we'll use an endpoint that is a fiber plane endpoint. It's a playground for your Hono applications. So it gives you some idea to interact with them, to send post requests. I put in my name. And what I will see now is not the output, but I will just see that I started a process with the instance ID. I see that the status still is running. Now, if I go to the terminal, I already see I got some ASCII art here. I also got the name, and I'm still waiting for the biography. So the ASCII art was finishing earlier.
That's strange-looking goose, but it is what it is. Good stuff.
Good stuff. Well, we can wait for it is also not so important, but then also this runs now locally, so you can spin up your Cloudflare environment locally using Wrangler. That's how it is supported. There's also the biography from that goose, but you can. This is also deployed, and then you can also go to the Cloudflare console, and you have more ways to interact with your workflow. So here we have that workflow example, and now if I go to one of those instances, I see those 2 steps that I've created, and then I can also go here. I don't have the ASCII art, but I see that was the output that was generated for me. I also see here the configuration of that specific task. So what I can do is I can set a limit of retries. So if something is failing, the workflow will continue retrying. And I can also set a delay time to do that, and I can do that independently on the task level.
There you go. That's pretty cool. So now let's take a look at the other side, right? So she's showing like, what is that? Like, is that Node, like
that
TypeScript?
Is TypeScript, yeah.
Yeah, so that's TypeScript. Like now we're going to take a look at Dapr using Java and specifically Spring Boot. And as I mentioned before, that Dapr is something that runs inside Kubernetes, but we heavily integrated with the Spring Boot ecosystem and also with Workers, so you can start Dapr locally without needing to deploy on Kubernetes. So what Nele is doing now is she's going to start like an application, like a Spring Boot application locally. Dapr is starting at the same time of the application, and it's connecting the application to the Dapr APIs where the workflow engine is running. And then what we can look into here is the source code on top, which basically is the workflow definition. And you will see kind of like the same ideas that we saw in TypeScript before. Instead of do step here, we have 3 things. We have like a context wait for external event. That's self-explanatory. Like we are starting a workflow and they're waiting for an external event to arrive. The event arrives with some payload. We check the payload, and then we make a decision in an if statement. Again, we are using Java. We are defining our workflow definition, the different paths that the workflow can take, just using pure Java. That gives you full flexibility of the Java language. You can see that we are checking if the decision is approved, that it's coming from the event, and then we are doing call activity, the approve activity, or the deny activity. So this is running. We have an endpoint that basically will trigger the workflow in the same way that we did before. So we can send a curl request to just start the workflow, I think. The second one, that one, yeah?
Yes.
So that one is pretty simple. We execute, create an instance that we get an ID. And if we look at the logs, you will see that now we are waiting for an event to move forward. It should be somewhere there. So here, like you see, it's here like waiting for an event. Probably it's too big. Waiting for approval, that's basically waiting for an event. And it will wait there depending on our workflow definition. We can say, wait for 5 hours. If nothing happened in 5 hours, trigger a different task. If not, wait for this event. And what Nele is going to do now, she's going to send that event with another request. So we are sending that request. It's hitting the same workflow instance, and then moving that workflow instance forward, basically finishing it up. Yes. So now you can see like the approval finished. Now the workflow finished as well. And again, we are just showing a single instance, but these systems are built to scale. The idea is that you can have like thousands of customers triggering these instances to go through these processes. And if you go to the UI now, we can take a look at like something that we are building in Diagrid on top of the Dapr project, which is basically, again, similar to what Nele showed for Cloudflare. We have a visualizer for these instances. This is kind of like the historical view, where you see kind of like all the things that happen inside the workflow, but also we have the graphical view that lets you like see what's going on with the execution. So in this case, we started, we waited for an event, and we didn't went to the deny activity, we went to the approve activity, and then the workflow ended. So this is all just to show you that no matter like if you're running again on the cloud or on premises or with Kubernetes, there will be always tools that will provide this kind of functionality.
Cool. Moving back.
Yes.
To.
And yes.
Was the demo that we did?
So as I mentioned before, right? Like if you are running on SaaS, you probably have your reasons to use cloud providers or services that simplify the management of the infrastructure. If you're running on Kubernetes, also you have some reasons to do that. You will need to learn a lot of stuff. I believe that it's very useful to learn that stuff as a developer. But no matter what, you will find tools to do these things. And again, for me, as a developer, it's kind of like important to understand how these tools are different and when to use them, because in reality, you probably will need all of them, not just one. So we wanted to build something for this presentation that actually uses Cloudflare and Dapr workflows together, just to demonstrate kind of like the different angles of how these things will work.
And of course, we have a Goose sticker store, so we brought also some Goose stickers, and we built a store where you can order them. And maybe before we order them, we explain how we build it, right?
Yeah. So the example is in that repository. It's called JNation 2025 under my username, Salaboy. If you want to check it out, there is a Spring Boot application and a Cloudflare worker, basically implementing the application that we're going to show. Why won't you start with the Cloudflare side of things? Yes.
Well, we use Cloudflare because it's close to the end user, and the Cloudflare worker will get some information from your browser. So it will get your location, and based on your location, you get a different sticker offering. And also, we have some dynamic pricing. The more people we have on the website, the higher the price gets, or the lower, I don't know anymore.
Something
but the idea is the more people, the price is changing. And for this demo, because we are all at the same location, we hard-coded in some location where geese are from. So you will see that. We don't use a workflow here, but we use a durable object to first store the total number of people that we have in the store. And we use a durable object later on to open a connection to the Spring Boot application for a WebSocket. So we can see updates, because once a person hits the order button for the sticker, we actually start calling the Spring Boot application for the ordering process.
Exactly. And on the Kubernetes side, I'm running a Kubernetes cluster in Google Cloud Platform, basically. I'm running it's a managed Kubernetes service. So I just created an instance there, a cluster. And then for running our application, we need to define a Kubernetes service and a Kubernetes deployment. And we need to containerize our Spring Boot application and share it, put it in a registry, right? So we have the application that runs the order of stickers, in this case, running inside the container, inside the deployment, being accessed by a service. And for that application, we have a different person. So you will be creating orders in our store, and we will have we will play the role of the warehouse employee that is basically validating your orders whenever the process requests them for validation. Yes. So the flow, you want to explain the flow?
Yeah, I think we explained already a little bit how it goes, but yeah, I think the idea again, you join the job, the worker in the background calculates your price and your product that you see. It opens a channel while placing the order to the Dapr, to Kubernetes and the Spring Boot application, and then the Kubernetes application will report back the status. It will check the stock with the warehouse. We have a service for that, and then we need wait for the warehouse approval. So that is a manual person coming in saying, yes, I approve the order, and then we start shipping to the customer.
There you go. At all times, we are sending events to the Cloudflare worker through a WebSocket. So the application can send you information in real time about your order. That's the idea, right? Now, I need to be clear. This is just the demo, so it might not work.
Let's see.
If you have your phones with you, we are going to be sharing a QR code where you can access the application to create orders. We have stickers no matter if the application works or not. So can you refresh the thing? Yes. You need to refresh the thing first.
Yeah, OK. I'm going to our really nice warehouse application approval front end.
Beautiful front end.
Beautiful front end, but now also going to the Goose shop. It will take some time to load. And if you refresh, I said already, you get a new region. But it is doing some stuff in the background. Let's see. Again.
All right. Is it working for you guys? No, because you cannot. Yes, is it? Yeah. OK.
Too many people on the top. Here we go.
Let me see if I can.
We have 24 people there. Hawaii is winning as a region. Lower Saxony, that's, by the way, the Emden goose, that's the traditional one. But I'm a fan of the Hawaiian one. Well, we order now.
Yeah.
And now we have to actually go to accept all the orders. Oh, my God, so many.
Yes.
OK.
You approve all of them before explaining what you are doing. There you go. Yes. So basically, if you get like a ship at the end, that basically means that your order was approved. Right?
Oh my God, there.
But look at that. So we are getting a lot of dynamic orders there. There you go.
I don't want to be that warehouse or person, to be honest.
There you go.
But yeah, I don't know if I approved my order, by the way. But yeah, I did.
Yeah,
so
you did.
It was updated. My sticker was approved.
And it was shipped.
It was shipped, yeah. It was already shipped.
So again, I think that like if you go back to the first screen, like the first screen of the application. So we went too fast, but like the first screen is basically using all the Cloudflare mechanisms just to understand where the user is, and also just using durable objects to understand how many connections are happening at the same time. And that's basically using that technology on the top, just to say that there are like 48 people joining these, and they are joining from different locations, right? Like in this case, 15 from this specific location. When we click the order button, it goes to the backend, and it starts that workflow. That's the steps that you are seeing next. And again, like that workflow, all the workflow instances are stopped by like the warehouse and waiting for that approval. So when we go and click the button there, like in the warehouse, what we are doing is we are sending an event to the workflow instance to say, yes, now you're allowed to move forward. So think about like the systems that you are implementing in your own companies when you have these sort of situations of, oh, I need to wait this person to approve my holidays, for example. Right? And that's part of the process. Once the holidays are approved, then you probably get a notification. That's the next activity in the process. These tools are used to build this kind of functionalities, but also are used to making sure that the application is resilient. Because if I approve you the holidays, but I don't send you an email saying your holidays were approved, you will think that your holidays are not approved. So making sure that all these things happen, or that if something fails, we can roll back some of the activities, is a pretty important part of these frameworks, like workflow engines that use like durable executions. And we keep getting orders. This is kind of like insane.
Maybe we should do a sticker shop at like one point, so it seems like people would order.
We definitely need to start charging for this, like instead of just doing it for free.
Yeah, but I think that brings us
to the wrap-up, right?
To the wrap-up, yeah.
Yeah, let's do it. So again, I think that we tried to show like a solution that included different technologies. They are all using this durable execution pattern to make your applications more resilient. If things fails on the Cloudflare side, they will be retried. If things fails on the Kubernetes side, Dapr will retry the workflow activities that we just defined. Again, we can stop and show you more code, how this is done, but that's all in GitHub, so you can explore it and even run it in your laptops if you want to. So if you have any questions, feel free to reach out. You need to know, in real life, you will need all these tools together. Depending on what you're building, you might need services, you might need Kubernetes, or you might need still VMs where all these tools will also work. Do you want to say something else?
No, well, maybe I think it's interesting to see that workflows are around for so long, as you mentioned, and to see how they are in different systems implemented. It's also sometimes interesting to see how different executions are handled in different tools. Like Dapr is doing it slightly different from Cloudflare. I found those patterns quite interesting, and also understanding those technologies. And I hope we spread a little bit workflow, durable execution love, and you start using those tools for use cases that you might have in mind.
That's really cool. So hopefully you learned something new. And if you have any questions, I think that this is time for Q&A, right? Let's do it. Yeah. Any questions? Yes, we have a question here. Microphone is coming. Yeah. Let's wait for that. Good.
So first of all, I want to praise your presentation. It was very great, and the great coordination, and yeah. So my question, the first one is related to the durable object from the Cloudflare. You mentioned that it's stateless, stateful, serverless function. So it's because it stores in the SQLite from the graph that you show. My question is how is that more performant than storing to a database? Like,
okay, I'm not complete I don't work at Cloudflare, so I don't know if I can answer that completely right. But the idea is that this object is, or that it's kept alive. You don't have to maintain it. So once you deploy the application and create the durable object, Cloudflare takes care of it, and it will be close to the region where it was deployed. And then it has those two things, memory, and inside it has the SQLite database. And you can spin those up quickly.
So I think that the difference is that you don't need to care about performance because Cloudflare will care about that performance. If you are storing in your own database, then you will need to fine-tune the database to make sure that it's performant, right?
Yeah,
I think that's usually the...
I think that makes sense because it's near to compute site. So yeah, the network I/O will be like fast.
Exactly.
My second question is related to the Ghost store that you showed in the in the beginning. Again, the durable object there. My question here is like you use durable object like WebSocket, so they can share the information between the users, and based on that durable object, then you send to the backend to Google Cloud, right?
Yes.
Okay, just want to make sure. Yeah, I understood.
So okay,
Yeah.
so I think that like we created durable object to store kind of like to open a WebSocket for the client, and then from the backend, the workflow in every activity is sending an event back via WebSocket, so it can be forwarded to the user.
Yeah,
Yeah?
makes sense. Yeah.
Cool.
Last question.
Go.
Sorry. So I think this one is like, but yeah. Does workflow, back to the workflow, does workflow always end?
Mm-hmm. Yes.
Okay. Imagine that in one activity, retry 5 times. After 5 times it failed. What happens?
So you have like in all these tools, you have like a retry mechanism that you can configure. You can say try at least 5 times with like these periods between the retries. So sometimes you want to wait like 20 minutes before retrying because you just want to make sure that you wait for something. And after that, usually the workflow state will be like in error.
Yeah,
so somebody will need to go and fix like something there and retrigger so that task can continue.
Okay, makes sense.
So you have all these mechanisms to deal with those kind of situations. And that's why we show the UIs, because it's important that when you have like 1 million instances, you want to see the ones that are failing probably quickly, and then in which task they are failing, and with which information they were failing. So if you need to check the information is right, or change the information, you can retrigger it for further processing.
I just put it up there, so
yeah.
So you see then the workflow is erroring, and then you can go into the task which one is erroring, so you also get the error log and the information.
Okay, thank you. I ran out of questions, so
good. Thank you so much.
Yeah.
We have another question here. We have another question. Another question there. Yeah.
Are the workers logs in Cloudflare still in beta? I remember that when I wanted to check workers logs, and there was a beta sign last time I checked.
Only for workers or for
For
workflow?
logs?
I think workers logs, only for workers.
I don't.
We can check. Yeah,
we can check. I'm not 100% sure because when did you know when you checked?
I think maybe 1 month ago. But because I think it's very important, right? This feature should become stable. I don't know. Yeah.
Imagine if you cannot see what's going wrong. That's something that you can always do with Kubernetes. You can see what's going wrong because there are tons of things that can go wrong. So yeah. We have another question there. Thank you.
Well, that's actually 2 questions.
Yep.
Can you talk a little bit about fault tolerance, error handling in the context of not specifically these tools, because I work mostly on on-prem scenarios, but in a sync environment, distributed systems environment, because I was hoping to, I don't know, maybe check a little bit about fault tolerance more than just setting a timeout.
Yeah. So remember that when you use this architectural pattern, I think that the retry and the timeout are the most important parameters that you need to set depending on the workflow that you are defining. When you talk about like fault tolerant, like again, like even if you're working on-prem, you can use Dapr workflows on VMs, right? Like that's not the problem. But you always need some sort of like component that will deal with the orchestration of the faults. Like if something is failing, somebody needs to know that something is failing, and you need to define what to do in those failure scenarios. I'm not entirely sure what tools are you using today to do something like that, but yeah.
So we have two scenarios. We have a simpler scenario where we use a dead letter queue in a sync scenario if the callback fails. But I'm most worried right now, and I mean right now, like tomorrow, about a scenario where we have like what I understood from this it's not really a question, it's more like a reflection. What I understood from this presentation is that you can spin it around multiple times, go on-prem or go on cloud, but you really need a state machine, right?
You need I think that's kind of like what you need to take away from this. It's like no matter what you are doing, and more like if you're working with message brokers and queues, you need something to understand what happens when something goes into the dead letter queue. And then have some sort of with workflow tools, you can set these timers, right? Like said, there's something sitting there for 5 hours. This needs to be escalated. That means running this custom code for that, right? And if you build that into your applications, then understanding how all that is architected is very difficult. When you have these tools, you will have the visualization of where things are, depending on things that are happening there, right? Like if you can see the failure, but also you can see that in 5 hours a task will be scheduled for fixing that failure, right? So I think that that's the problem usually with event-driven systems that are like very difficult to track what's going on and figure out what to do when something goes wrong. So hopefully that helps.
We have a lot to think about, but thank you.
Cool. Any other questions? We have one more question here. Yes.
Sorry, just come up the idea of like, imagine that you have activity that runs out of memory, like you are running and then it runs out of memory. We know that it will happen again. Do we have any policy to stop that? Like if it's out of memory, we stop retry because we know that it will fail again?
I think that question applies to any like the application itself, right? Because in this case, the activity will run as part, like you define it as part of your application. The only thing that the orchestrator does is call you to say, execute this, and send me the results, right? So it actually depends on how do you configure your applications more than the orchestrator itself.
So you are saying that we can have some like try-catch mechanism on there to. Okay. In that sense, like it might happen like we don't know because it's unexpected, right? So we have to put try-catching every block of activity.
I don't think that you need to put a try-catch, but you will see a task failing and the error will be like I'm out of memory, right? So that will signal you to see that like, okay, this is failing because it's out of memory, so you will need to fix the configuration of that application.
So imagine that workflow is in the middle of in the second activity.
Yes.
We can fix that in the middle of the second activity and then let it continue to end. Okay, nice. That's cool.
that's the main idea, right? Like you can continue from where you were instead of starting from scratch, because you can check what was executed before.
Oh, great. Yeah, thank you.
Good stuff. I think that we are running out of time. Is there one last question?
Oh yeah, the stickers are somewhere, right?
That's true. So we have stickers. Like if you get a sticker after your order, you can just pick one sticker here. And thank you for coming, and we appreciate you being here. Thank you.
Thank you.